Okay, nobody came, so I hope you can see this record next time, but it will shortly lessen. I hope you can see it. Okay, let's remember what we discussed previous time. We say that we have bootstrap when we have some data samples and we can oh, somebody came. Hello. I thought that nobody came and start, but okay. I think today we on this lesson. Okay. Next time we discussed Bootstrap, and they say that we have some data, and we can make some sample from this data, and for every sample we can learn some algorithm, for example, model 1, model 2, model 3, and etc. And when we speak about, for example, Bayesian or random forest algorithm, we need to learn our model in parallel. And when I think some learning process for every model. And then we get some result from first model, second and third model. For example, result 1, result 2, result 3. And then we can apply some aggregating function. And I see the hand. Yep. Do you have a question? Oh, okay. Sorry. Okay, we need to apply some aggregating function, and for example, take the mean value from these values, and we get some final result after these models. And what some specific thing for this algorithm? They said that we learn our model parallel, but today we will discuss some new algorithm for us, and it's the gradient um, boosting algorithm. Um, I see question in chat. No, it's not first class. It's I think 6 or 7 classes. But nice to meet you. Okay. Gradient boosting. Mm, Today we will discuss gradient boosting on decision tree or GBDT algorithm. What's the main difference on Bayesian algorithm, which we discussed previous time? I remember it for someone who missed previous lesson that we discussed Ansible algorithm, and it was Vialykh and random forest algorithm, and it's just algorithm machine learning when we learn our model parallel and then apply some aggregating function for getting the final result. And today we will talk about the gradient boosting and the main difference on previous algorithms groups is learning our model just sequentially. So we learn model and then they learn next model using error previous model, and it's consistently process. So for example, we have sorry, we have some oh, it doesn't see. We have some model, and after learning, they know that this model has some error. You can give this error for next model, and we hope that next model can fix this error. And next, we can use hundreds models for this fixing our error. So the gradient boosting is really powerful algorithm because early then we discussed, for example, trees or some simple algorithm, linear regression or logistic regression. We said that every algorithm can make some error, but Ansible group of algorithm helps to fix this error because we use some models and we can fix our error from first model with helping second, third models. So I worked in the bank, and when machine learning only appeared in banking areas, we use some linear or logistic algorithm for credit scoring task. For example, we have some people and this some men, and this man want to get money. And we want to know, can we get money or no? Because we want to turn back this money. And we can ask some questions and get some data about this person and make decision, give money or no. And the previous first algorithm for this task, we discussed linear regression and logistic regression, for example, but it's a classification task, so we can use logistic regression. But now many companies for this task use exactly gradient boosting because we can take decision tree algorithm. For example, we have tree and we have another tree and some amount trees, and when we aggregate result these trees, we can get exactly enough score for making decision about credit score. Okay, I can say that early gradient boosting also applying, for example, in Yandex for search, for increase search quality, and you can read some article about this. When we speak about gradient boosting, you need to know that many companies increase quality search with this algorithm. And yeah, some variant of gradient boosting method which uses decision trees. So let's try to discuss some math for this algorithm. For example, we want to learn some regression task. And our loss function for this task like this expression. So you have target and you have some prediction after your model. And you want minimize this function because you want this error targets and your prediction will minimal. So let's build some composition from basic algorithm. What I mean, let's imagine that you play in the play golf, and you know that your goal is this. You need to yeah, is your goal. And you start from this point. You take your ball and your first um, your first sorry, I forgot this word. Throw or shot for this ball is this point. And next, you understand that your error this distance, and you thought, okay, I can fix this error if I beat next time, and you cast next time, and you in this point now. So when you move to your goal, you need to make less steps, and at the end we hope that we achieve our goal. So it's intuition for gradient boosting. And let's try to make composition algorithm, for example, first and second and third model for our task. And if we learn only one algorithm, I think the quality of this model will low. But we know but we know error this model, and we can learn with this error other algorithm. To be honest, you can take different algorithm for this for gradient boosting, and your weak algorithm, it could be, for example, linear regression or something else, but often we use decision tree. And for example, you know that your first model error, it's 10. You want that next model fix this error, and yeah, then you get result that you expected. So, other words, if your second model predict different between real value target and prediction the first model, it helps decrease our error for all our composition. Okay, it's logic for a gradient boosting algorithm. So if we speak about loss function, you want that on next step your error will decrease than previous or now step. Okay, if we know about Taylor function, you know that every function you can approximate with Taylor functions. And it's also analogically situation, because for example, you have some function and you take other function from Taylor row, and you take first function, and it's not good approximating for your function. But you can take other functions in Taylor row, and you get more quality, increased quality for your function. Okay, let's try to see notebook. And first, I want to demonstrate you action what we discussed now. Okay, we need to import some libraries for our task, and classical library pandas NumPy, matplotlib for visualization our data, and specific classes from sklearn. It's sklearn Ansible and tree, because today we want to try gradient boosting regressor and decision tree regressor. But decision tree regressor, I hope you know, because we discussed it previous lessons. But the gradient boosting regressor, it's new for us today. Okay, generate the data. Let's create some data set, and we have X and we have Y. So it looks like this, just some parabola. Now I want to show you logic of gradient boosting. You have decision tree regressor. It's just only decision tree. It's one algorithm. It's not ensemble of algorithm. And now you take decision tree and okay, you need to choose some parameter max def for your tree. And next, let's see some visualization for decision tree. You see that some feature for dividing your data, and no, so I think you familiar with this visualization. It's just one decision tree, but we want to. Okay, let's use this model, and when we use it's this model, you get some prediction after model, and you know real value, your target. And now you can calculate the difference between these values. And when you get different, you can learn your next model on this error. And you just say, okay, I get error for first model, but I have next model, and I want second model fix error from my previous model. And let's try to create this result after first model. But now we need to calculate error after first model and fit this error for next tree. It's second tree for us, and we just take decision tree regressor with the same parameter max def. But now we fit our model data after calculating a difference between our result after first model and target, so real value. Okay, and let's try to visualize our result. We take the second model and make predict. And next, you see that predictions after two models, where your second model use error previous model, is better than this graph. Your first tree can't approximate your data. And next, we just need to add algorithm in just in case some trees. But of course, in real life, we don't write this algorithm manually, because we have some libraries, for example, sklearn, and next we can use third tree and learn it on our data, our error previous models, but usually we use ready algorithm, and yeah, its result after three models you can see that our third model some fix error previous decision trees. Okay, and now I think we ready to use gradient boosting from sklearn library. So we also have some important parameter for this algorithm from sklearn. Max def is just parameter from decision tree. You need to define depth of your tree and n estimators, and it parameter from like bagging. We discussed it previous last lesson. It's just amount of model in your Ansible. For example, you have in this case 3 trees, and 3 trees participate in your gradient boosting. Gradient boosting you can apply and regressor and like classifier. So you can go to sklearn official documentation and read some information about gradient boosting and gradient boosting modifications. Maybe some math about this algorithm, for example, regularization and other details, how it algorithm works with missing values, because it's really important case when you have the big, huge data set, but in real life, our data set has lots of missing value and information not enough for our task. We need to clean these values and fix it in our data. So categorical features. As you know, categorical is just non-numerical values. For example, when we try to describe old or salary or some prices, it's numerical values because it just units. But if we talk about some colors, for example, or some I don't know, colors, for example, red or yellow or orange, you need to fit these values for your model. But first, you need to transform these values, and in sklearn gradient boosting also can do it. Okay, so I think you can read this documentation. You can find this some visualization, some details about sklearn, but now we want to concentrate on Ansibles and gradient boosting algorithm. Now I want to show you a few things about gradient boosting. As I said above, we need to choose hyperparameter because hyperparameters is very important thing for any model which you use. And you need to choose learning rate, you need to choose n estimators, and to be honest, actually you need to choose depth of your weak algorithm. Okay, now we can see different values for n estimators, 3 and 200. You see that if we have lots of data and we take not enough amount our models, so n estimators, you get underfitting because your model can't remember and can't learn all dependencies in your data. But if you take more values for an estimator, you see that okay, it's a good approximation, but you see that model try to learn every point, and it's not good. I think it's overfitting for your model. You need to find the optimal values for these parameters, because if your model overfits, it's low generalization abilities, and then you give new data for your model, you just um, um, don't get a good result for this task. And really cool thing for gradient boosting, it's early stopping. What is it? When you build your gradient boosting algorithm, you need to choose optimal values um, for n estimators, for example, for max def, and you just create some list with different values, possible values for numbers of estimators. And from this list, you need to choose some optimal value. But how you can do it? You need, you can sort it out every value, but it's not effective. And you can use parameter n iter no change, and it means that your model, when your result will be optimal for you, model doesn't use next values for n estimators and just stop. So it's parameter which responsible for stopping your model when you get necessary result. And if you have in your list another parameters for example, n estimators, it doesn't mind, because your model have optimal value, and you don't need to use other values from your list, because yeah, you get optimal result. And yeah, when we build the graph with learning our model, you can see that MSE, mean squared error, you can see minimum value, and this optimal value for your mm, in your learning. So the optimal number of trees in this point. And now, for example, you can say that, okay, I get this value and I don't want to know what happened next. I just stop my model. And for example, in this point, you can mm, make early stopping. But of course, you don't know in this moment that it's optimal value. But it's just some limit on limitation on your error. Uh, okay, I think in this notebook that's all, but I want to show you some really beautiful visualization. Yeah, I think here. On this and this website, you can play its different parameters in your uh, gradient boosting algorithm, and you have really good explanation. So, yeah, how it works. You have some decision trees, and on this graph you have some regression task. You want to, yeah, we take a two-dimensional regression problem and investigate how a tree is able to reconstruct the function. And you can use some values for your trees and see how it impacts on your your prediction. So also, yeah, different gradient boosting visualization. You can choose some interesting distribution of your data and changing tree depth. So this hyperparameters, hyperparameter, and you need to choose it when you learn your model. It's a really good visualization for understanding how it works. Um, yeah, I think you can play this, and also gradient boosting interactive playground another. You have 30 trees, and you can build all parameters, learning rate, or number of trees, depth your trees. You can rotate your data set, and it's really good for your understanding. Okay, next I want to show you okay, we can discuss this notebook fast, and next I can show you the really good gradient boosting algorithm for your tasks. Okay, in this notebook, we want to compare bagging and gradient boosting. What is the bagging we discussed last time, and also I remember you about it in the beginning our seminar. Now we need to generate some synthetic data. It's just two group in scatter plot. And let's try to build a Bayesian regressor with the decision tree weak algorithm. And let's try how change our result if we use different values from this list. Yeah, you see 1 trees, 2 trees, 20 trees, 100 trees, and etc. You can see that in some moment our approximating our data stop changes. And you see that I think, for example, maybe 100 trees. And when we move to 500 trees and etc values, you see that your function almost doesn't change. But now you can take gradient boosting regressor. Gradient boosting regressor. I remember that now we see Bayesian regressor. And on gradient boosting regressor, you see that in some moment our model starts overfitting because you see that it's really strong adaptation on every point. Our model needs to have generalization abilities, and it's really not good for us. So you can fight with overfitting that some parameters um, in your formula in this expression, and you can control your learning and stop not stop um, influence on your overfitting. So you can see how with some learning rate 0.1 and with different sizes how we can approximate our data. Yeah, you can see that Bayesian algorithm faster become stable, and in some moment 50 trees our values, our result stop changes. But gradient boosting we see some changes now. And on the test samples, you see also some stability in the Bayesian algorithm, and in gradient boosting you see that optimal result you get faster because in this point your loss less than for Bayesian, but when you add some trees then you just meet overfitting and your loss start increase. Oh, sorry. Now we can apply our gradient boosting algorithm for digits, and you can see just decision tree classifier with one algorithm decision tree. Then is random forest with some amount of decision tree, and you can see that accuracy after one decision tree less than answerable in random forest classifier. I remember that remember you that random forest is just begging algorithm with decision tree. So it's really good metric for our task. And now you can see how increase accuracy if we use different values for answerable sizes, so for n estimators. And you see that your accuracy increase, but in some moment it's just stable and stop changes. But it's a random forest classifier. In gradient boosting, we have the same, almost the same situation. In some moment, our result stop changes. And now I think we can discuss the most popular algorithm basic on gradient boosting. It's XGBoost, LightGBM, and CutBoost. If we go to Kaggle platform is competition in data science. So you can choose some very popular competition and just see how many notebooks, how many codes. I can see you. Yes, we have some code, and you need to, for example, like GBM. And you see how many how many notebooks use this algorithm. I think really popular this algorithm become after Kaggle platform because very often the good result in competition people give with this algorithm. So it's XGBoost. It's all algorithm use gradient boosting with different modification. So it's XGBoost documentation. You can see installation guide and maybe a quick start. And also see some tutorials about this. The next algorithm is LightGBM. Also, we have documentation and quick start. You can use it, and Yandex decision. It's CutBoost. Cut because it works with categorical data and without adding, transforming your data. And the main difference between these three algorithms, I think it's just decision tree shape, because ways of building your decision tree in this three algorithm difference. For example, in light GBM, you can get very unsymmetric mm, unsymmetric asymmetrical decision tree, and uh, this algorithm usually applying when we have a very large, very huge data set. We use leaf, wise tree, grow ways for building our tree. In XGBoost, we have a symmetrical shape of our decision tree. It framework maintain parallel calculations. Also, it use some regularization, and cat boost algorithm really cool because we have worked with categorical data without preprocessing, and it's very detailed documentation. You can read this, and also you can try to this code quick start in Google Colab. Also, you can see different implementation on different languages, but I think you can make it own. So really interesting materials in educational materials, because you can read reference papers for this library, and yeah, some historical information about burning this library. I sent you all useful materials about this topic. I share you this notebook and this notebook. You can play with this and send links on this visualization. And I think it's all information on this lesson. Thank you for your coming. Have a nice evening.